Now that we've talked about theory, we want to spend a little bit of time looking at examples where we need to figure out actually what is the limiting reagent, not just where we should use it. All right, so the general strategy for limiting reagent. I'm going to put a little caveat. There's more than one way to do this. Your book talks about a different method, but this is the method that I'm going to talk about. I think it works well, and it also gives you the theoretical yield for free out of it. But what we're going to do is we're going to take each reactant in our mixture, and we're going to use stoichiometry to figure out how much product we can make for each of them, right? So we're going to imagine that each of them can make some product, make the same product, and see how much they could make. And so we're going to get different amounts of that same product, and whichever reactant corresponds to the lower amount is the limiting reagent. Okay, so whatever corresponds to the lower amount, that reactant is the limiting reagent. All other reactants are in excess. And I forgot to mention, that amount of product is theoretical yield. That's why I use it this way, because you get the theoretical yield for free. That lower amount of product, right? This is limited. A lot of times we look at that higher amount and use that, but that is what we could make with our excess reagents, but we run out of the limiting reagents. These will be left over. You have more, you could make more product with that ingredient, but you don't have your limiting reagent. The other ingredients have run out. You have a mixture of 10 grams H2 and 10 grams O2 set to react according to the following reaction. Which reactant is the limiting reagent? What do we want? You can see it's limiting reagent. And so limiting reagent is an idea that always has a process associated with it. We figure out the possible yield for each reactant. Whenever you're told you want limiting reagent, that's what you need to do. And so we want to look, do we have masses for our reactants? 10 grams H2, 10 grams O2, we're cooking with gas. So what we can do is we're going to need to do two separate stoichiometry problems. But each of them is going to be the same type of stoichiometry problem that we've worked through previously, the same three-step method.
All right, so you have a mixture of 10 grams H2, 10 grams O2, react according to the following reaction. Which reactant is the limiting reagent? All right, so when we see that right there, when we see that language, limiting reagent, that's what we want to key in on. That is something, that is a process that we want to, that we can deal with and we can go through. When we look here, the other kind of language, sometimes it won't be so apparent that like you need limiting reagent. But one of the things we can see is that we are given a mass of reactant and the mass of another reactant. So in this problem, you're explicitly told, calculate limiting reagent. But whenever you are given the mass of two reactants, you have to figure out what the limiting reagent is. There is one stoichiometric ratio where they would be at a perfect reaction mixture. But in general, if you just have some of the first reactant and some of the second reactant, when you mix them, you are pretty much guaranteed that one of them will be the limiting reagent. Because there's only one possible mixture that doesn't leave a limiting reagent, where they're actually at 2 moles to 1 mole. But generally, everything else leads to limiting reagent situation, where one is in excess and the other one's going to run out first. And so when we want to go through that process of figuring out what the limiting reagent is, there are going to be a couple ways to do this. The book talks about one way. I'm going to walk through a way that's based around calculating potential product. If you have a different way that you like, that works. This way that I'm going to talk about, it works, and it gives you, the reason why I use this one is it gives you a little bit of free, you get kind of some free information coming out of it that we'll see at the end. So what we're going to do is we're going to calculate potential product for each. So we're going to do 2 stoichiometry calculations. Okay, so what I'm going to do is I'm going to start with this. Basically, I'm just going to say basically 10.0 grams of H2 to how much H2O. Okay, because that's the product. And so I go through that process. I know how to do that stoichiometry. 2.02 grams of H2 for every 1 mole of H2. That's my molar mass. Then I use my reaction coefficients. 2 moles of H2 for every 2 moles of H2O. Those are my reaction coefficients, pulling them off the balanced equation. And then finally, molar mass of H2O is 18.02 grams. So what I have calculated, if, forgot a zero there, 10.0 grams of H2 reacts according to this equation, and if it reacts perfectly, right, this is stoichiometry calculation, so this is a theoretical yield, and if it goes perfectly, you have enough to create 89.2 grams of water. Okay, so we can do that calculation. So that is one of our reactants. But we also have this other reactant. So the other question I'm going to ask is, if I have 10 grams of O2, well, how much water can I make from that? Okay. I figured out for H2 how much water? Well, for O2, how much water? And again, that's going to be the same type of stoichiometry calculation. I use the molar mass of O2 this time. So 32 grams of O2 gives me 1 mole of O2. I use the coefficient on O2, which is 1 mole of O2. But on this, and actually from this, 2 moles of H2O. And then this is the exact same molar mass, 18.02 grams for every 1 mole of H2O, because I'm going to the same product. And when I calculate that, I get 11.3 grams of water. So what this tells me, if 10 grams of H2 reacts perfectly in this reaction, you'd make 89.2 grams of water. If 10 grams of O2 reacts perfectly, you get 11.3 grams of water. 11.3 grams of water is lower than 89.2, right? What that means is that since this value is lower, you're not making 89.2. You're only going to make 11.3. You only have enough oxygen to make 11.3 grams of water. All of this H2 cannot react. So because this is a lower number, that means this is your limiting reagent. The oxygen that you have is the limiting reagent. And you also now know that for this mixture, 11.3 grams of H2O is the theoretical yield. That is the total amount that can be produced. Yes, you have enough hydrogen to make more water, right? You could make more water with the hydrogen that you have present, but you are limited by how much oxygen you have. The oxygen is going to run out. If you want to make all of this water from all this hydrogen, you need more oxygen. You only have enough oxygen to make 11.3 grams of water. This lower value indicates that this substance, oxygen, is a limiting reagent. So whenever you have two reactants like this, whenever you're given two reactant masses, you have to figure out which one's the limiting reagent, and that is the only way to determine what the theoretical yield is. That is what is limited. What is limited is this total amount of product that you can actually make. And so whenever you're dealing with a real reaction, you need to determine this limiting reagent to figure out, what do I have, what am I going to run out of first, and how is that going to impact how much I can actually make whatever I'm trying to produce. But again, there's more than one way to come up with limiting reagent. The book talks about a different way. You can find plenty of other methods online. I just like this one because you do two kind of calculations in parallel that are pretty similar. So you're doing two of the same thing, and then you're just comparing a number at the end to figure out limiting reagent, and for free, you get the theoretical yield. That's what I like about this method, that you get the theoretical yield. There are other ways that give you the limiting reagent that then you just have to do another calculation to determine theoretical yield. Because that's what you normally want, I just prefer to get them for free. You might as well do one calculation. The whole point of determining limiting reagent is to figure out what you are limiting, which is the yield. So I prefer this method. But certainly there's other ways that work.
Participation 615, question 4. What is the largest amount of water you can expect to produce from a mixture of 5 grams H2 and 25 grams O2 based on the equation below? The reaction is 2H2 gas plus O2 gas yields 2H2O liquid, and gave you the molar masses for the H2, the O2, and the H2O. This is the 4th question on participation 615, due Monday, June 15th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, what is the largest amount of water you can expect to produce from a mixture of 5.0 grams H2 and 25.0 grams O2 based on the equation below? Hydrogen and oxygen are making water, and you've got the molar masses of each of those substances given. Okay, just one video left. Looking for any more questions on participation 615. I'll see you in that final video.